Let me ask you a question. So we know this series is going to diverge, meaning as we add up each term, the whole thing is just going to get bigger and bigger and bigger and bigger and bigger. It has the potential to reach, let's say, 7 million if you wanted to. But my question is, how many terms do I need just to reach 20? So this is our n equals 1. This is one term. This here would be 2 terms. How many terms will I need in order to reach 20? So press pause and have a go. Okay, so the trick is to use Riemann's upper and lower sum. So to track this 20, because if you add up, I don't know how many terms, you're going to come up to 20. The trick is well, you want this to be 20. So the trick is to track this in between two things. So use Riemann's upper and lower sums to track it. So let's answer the question. So first we need to simulate this series. So the way we would do that is to deliberately create a width of 1, create a width of 1, create a width of 1. So this area here would represent this. This area here would represent this. So we want to simulate this series. The way we would do that is just to create an area in such a way that this area represents this area represents this, and so on. But the thing is, the last area would be n minus 1 here. So well, we've done this before. So if you don't understand this, track back to one of the early videos. We have done this. So we want to simulate the series here. So this area would represent this area would represent this, and so on. The last area would be this. So already, hang on. So already this whole thing, we know that already this whole thing is bigger than this thing. So now if I add something to this side, then this side will definitely be bigger than this, because already this thing here is bigger than this thing here. So I'm going to add something onto this. So if I add this thing here, assuming this is positive, then the whole thing here will definitely be bigger than this. Well, I'm going to add 1 over n. This here will be positive because n is always in the positive realm. So I'm going to add on a positive amount. Now this whole thing here is definitely going to be bigger than this, because already this is bigger than this. I'm going to add an extra amount. So now the whole thing here will be bigger than this. So because I've added 1 over n, then now this thing here is now Sn. Because currently it's not Sn. Currently it's this. Sn well, now the whole thing here is Sn. So currently this thing is bigger than this thing. I'm going to add a small amount, 1 over n. Now this whole thing here now is Sn. And Sn here must be bigger than this thing here. So Sn is bigger than this thing here. So now using Riemann's lower sum, we want to simulate this. So using Riemann's lower sum, just by the nature of Riemann's lower sum, you start at a half. So this area here, because if you use Riemann's upper sum, the first rectangle would be, the first square or rectangle. This thing here would represent this. But then you using Riemann's lower sum, the lower sum would actually represent the second term here. It starts here. This would represent this, and this would represent this. So hang on, using Riemann's lower sum, this area would represent this. This would represent this. This would represent this. And then the last one, the last one would represent this. So now, hang on. So wait there. So now currently this whole thing here is less than this thing here. So now I'm going to add an equal amount to both sides. I'm going to add 1, because I ultimately want Sn. I want to create a series Sn, the partial series Sn. So currently it's nothing at the moment. So if I add a 1 here, then this whole thing here will become S capital N. So I'm going to add an equal amount to both sides. That will then take me to here. Now this thing here is Sn, And then this thing here, well, if you evaluate this, if you integrate this, if you integrate this, we've done this many times, that will then give you this. This will be this. So what we've got here is this. Hang on. What we've got here is the partial series has to be less than this whole thing here. So earlier we said the partial series using Riemann's upper sum, the partial series will be greater than natural log of n. Just now we've just established that the partial series must be less than this thing here. So basically Sn is trapped in between here and in between here. Okay, so I will continue in the next video.